Okay, we're continuing with our lesson that dealt with our rational functions, which are functions that are in the form of quotients of polynomial functions. And we looked at how to find the domain. We looked at how to find the vertical asymptotes. We looked at how to find the horizontal asymptotes. So what we want to do now is we want to look at how to graph our rational polynomial functions. And I find it easier if you go through a set of steps to do this, because there's some of the things that you'll find in one step that will help you in another. And we're going to be able to graph these with just finding 1 or 2 points. So the first thing we want to do is to determine symmetry. Then we'll find the y-intercept, the x-intercept. We'll find our vertical asymptotes, our horizontal asymptotes, and then we will plot at least 1 point basically on each side of the asymptotes. We can also do it on each side of the x-intercepts. And with that, you're going to come up with a fairly accurate graph of some complicated functions. So let's begin and look first of all at the polynomial function f of x is equal to 3x over x minus 2. Now, if we were talking about the domain of this, we would have to eliminate 2 from our domain. So it would be from negative infinity to 2, and then from 2 to positive infinity. Okay, we want to look first of all at dealing with symmetry. Now, to find our symmetry, we substitute in negative x, and we would get 3 times negative x over negative x minus 2, which gives us negative 3x over negative x minus 2. Now we can see that that's not the same function as we started with. If we factor out a negative 1, it's not the opposite of our function. So for this one, we have no symmetry. If we find our y-intercept, well, you do that by plugging in 0 for x. This was step number 1. This was step number 2. We plug in 0 for x, so we would have 3 over 0 times 0 minus 2, which gives us 0 over negative 2, or 0. So our y-intercept is 0, 0. Now, anytime your y-intercept is 0, 0, then 0, 0 will also be an x-intercept. But you can have more than one x-intercept. You can only have one y-intercept, but you can have more than one x-intercept. So let's find our x-intercepts. We do that by setting our function equal to 0. Now, the only way a fraction can equal 0 is if the numerator equals 0. If the denominator equals 0, it's undefined. So in this case, we get x equals 0. So again, we have 0, 0. Okay, we want to find our vertical asymptotes. Vertical asymptotes occur where there's no common factor with the numerator and denominator. Well, there's not, because we can't factor that denominator, so we have no common factor, and where then the denominator equals 0. So that would be at x equals 2, is our vertical asymptote. We find our horizontal asymptotes dealing with the degree. Well, if we look at our function, the degree of our numerator is 1, the degree of our denominator is 1. So what we had was, when the degrees were the same, then it was the ratio of the leading coefficients. So the ratio of my coefficients would be y is equal to 3 over 1, or y equals 3. So we're going to have a horizontal asymptote at y equals 3. Now, if we go through and we start plotting this information, And again, I'm just going to draw one. I know it's not as accurate, but we're not dealing with our points here. Well, we can use, let's try using one of our axes. We said in this case that we had no symmetry. We had a y-intercept at 0, 0. That was also an x-intercept. We had a vertical asymptote at x equals 2. We had an horizontal asymptote at y equals 3. Now, what we need to do then is figure out from this point what our graph is doing. Okay, let's review what we know. We know at a vertical asymptote, your graph is either going toward negative infinity or positive infinity. And on each side, we're going toward either positive infinity or negative infinity. For horizontal asymptote, you're approaching a value. And one thing you want to remember is with horizontal asymptotes, you're talking about what's happening as your x gets super small or super big. You're talking about the end behavior of your graph, not what's happening here in the middle. So it is possible that you may cross a horizontal asymptote near the origin. It's an asymptote out toward the end. A vertical asymptote you will never cross because that number's not included in your domain. So for verticals, we're always going toward infinity. For the horizontal, we're going toward numbers. So we can use some reasoning. Now, we said to pick a point on each side of the x-intercepts and of the vertical asymptotes. So let's just pick a point on each side. We can also use some reasoning. In this case, is that for this asymptote here, our point is on this side of our horizontal asymptote. So that means that we're probably going toward negative infinity here. But let's just pick a point and plug into our equation. We want it on each side of 0, so we could pick negative 2, 1, and then we're going to want 1 on the other side of our vertical asymptote. So let's pick 3. Okay, our function, if you remember, it was on the other page, but it was 3x over x minus 2. So if we plug this in, we plug in negative 2, we're going to have 3 over negative 2 minus 2 would be negative 4. Excuse me, this was 3x over x minus 2. So we're going to have, was 3 times negative 2. So 3 times negative 2 would be negative 6 over negative 4, which would be a positive 3/2. So at negative 2, we were at positive 1.5. At 1, we would have 3 times 1, or 3, over 1 minus 2 would be negative 1, or negative 3. So at 1, we're at negative 3. So this gives us the idea of what we were talking about. Our graph's coming down. It's going toward negative infinity, and it's approaching 3 from below that horizontal asymptote. And if we pick 3, we're going to have 3 times 3 is 9, over 3 minus 2 is 1. So at 3, we're up here at 9. So that means we're going toward positive infinity, and then we're going to be approaching 3 from the top. So that gives us a fairly good picture then of what our graph looks like. And I wanted to just show y'all how close we could get to our graph. And so I've plotted it on our graphing calculator. And so if we graph that, then you can see from our graph that we're fairly close. We've got a good sketch of what our graph looks like. And this doesn't show up the asymptotes or anything. So with just a few points, you can come up with a fairly close graph. All right, let's look at another function. And we're going to look at f of x equals 2x squared over x squared minus 9. Okay, the first thing we want to do is look at our symmetry. So we're going to plug in negative x. We would have 2 times negative x squared over negative x squared minus 9, which gives us 2x squared over x squared minus 9. So this one will be symmetrical about the y-axis. We got the same equation as what we started with. Now, you're going to be able to graph these even if you don't deal with the symmetry. It's just going to make it a little bit easier and less work when we get down to the step where we're picking points, because then we can just reflect, do one side and then just reflect it. Okay, our y-intercept, we'll plug in 0 for x. And we're going to get 0 over 9, which is 0. So again, we have 0, 0. To find our x-intercept, we set our function equal to 0. And the only way that a fraction can equal 0 is if the numerator equals 0. And so we have 2x squared equals 0. So again, x would be 0. So we have the point 0, 0. And that was our only intercept. We want to find our vertical asymptotes. To do that, we first of all see if we have any common factors with our numerator and denominator. So we would factor our denominator. And we have no common factors. So then we set our denominator equal to 0, and we're going to get x equals 3, x equals negative 3. So we're going to have 2 vertical asymptotes. Now you can only have one horizontal asymptote. You can have several vertical, but you will only have one horizontal asymptote. Well, in that it dealt with our degree, and the degree of our numerator is 2, the degree of our denominator is 2. So we have the same degree, so it's the ratio of the leading coefficients, y equals 2. So this is the information that we have. Let's go through then and graph it. Okay, we know we have y-axis symmetry. We have intercepts at 0, 0. We have vertical asymptotes at x equals 3, x equals negative 3. We have horizontal asymptote at y equals 2. So that gets us our asymptotes. Extend that one just a little bit. Okay, now we need to know, well, what is our function doing? So now we're going to need to get us some points. And we get a point on each side of our asymptotes and on each side of our x-intercepts. Since we know we have y-axis symmetry, we only have to do it on one side and we can reflect it. Now, you can use some good common sense in doing this. We're still going to pick a point. Let's say we're going to pick 2, and we're going to pick 4. That gets us on this side of our x-intercept. and on this side of our asymptote, and then we have one on the other side. And then we're going to reflect it over. But before we do, and I'll always like to use common sense first and then pick a point just to check myself. Since I don't have any more x-intercepts, then I can't cross my x-axis here. So that means I've got to be on this side going toward positive infinity. I cannot be going toward negative infinity here. And so my thinking is I'm going to have my graph here, then approaching my horizontal asymptote, reflect that across my y-intercept, and it would be the same thing. And now I've got my point here. We can cross our horizontal asymptote near the center, but since we have symmetry across that y-axis, then it's going to have to be going in the same direction. So most likely we're approaching our negative infinity on that side and then reflect it over here. So that's what I'm picturing my graph to do. Let's just pick a point. Now our function was 2x squared over x squared minus 9. So if I put in a 2, well, 2 squared is 4 times 2 is 6. 2 squared is 4 minus 9 would be negative 5. So I have negative 6/5. So at 2, I'm about here. So that's going along with what I was thinking. And then when I pick 4, well, 4 squared 16 times 2 is 32. 16 minus 9 is 7. So 32/7, which would be 4 and 5/7. So 1, 2, 3, 4. It would be about here. So I would be going toward negative infinity. I'm going to reflect that across my y-axis. I would be going toward positive infinity and then toward my horizontal asymptote. And then I'm going to reflect that. So again, with just a few points, we have a fairly accurate graph. If we want to go to our graphing calculator just to check this one, then we would put in y equals, let's clear up what we have, and we had 2x squared divided by parentheses. Remember, you have to put that denominator in parentheses, x squared minus 9. And then if we graph that, we came up pretty close. And we did it with a few points. Now you may say, well, all I need to do is graph it on the graphing calculator. It's true that you can get a graph, but it's not always true that you have understanding then of what your equation is telling you. And you have no understanding then of how to make that equation so that it would do what you're wanting and have an understanding of what's going on with your equation. So it's real important that you graph it first, and then if you want to check it. Now, let me do just one more of this, and then we're going to look at our slant asymptotes, but I do want to go through one very quickly. X to the 4th over x squared plus 2. Okay, if we check this for symmetry, we would plug in negative x, and so we would have negative x to the 4th over negative x squared plus 2, which is going to give us x to the 4th over x squared plus 2. Since all of our exponents were even exponents, then we have an even function, so is going to be symmetrical about the y-axis. If we find our y-intercept, we'll plug in 0. We're going to get 0 over 2, which is 0. For our x-intercepts, we set our function equal to 0. And our numerator has to be 0, so x is 0 and y is 0. Now for symmetry, or for the vertical asymptote, remember we check for common factors. We have no common factors because we can't factor that denominator. That denominator will never equal 0, so we have no vertical asymptotes. Horizontal asymptotes, the degree of our numerator is bigger than the degree of our denominator, so that means we have no horizontal asymptotes. And that's the reason I wanted to do this one, is because I wanted you to realize we don't always have asymptotes when we have rational functions. So if we graph this one, we had 0, 0 as our point. We did have y-axis symmetry, so all we can do is pick some points. I'm going to pick 1 and 2. Now, if I put in a 1, my function was x to the 4th over x squared plus 2. So I would have 1 over 1 plus 2 is 3. So at 1, I was at 1/3. I can reflect that. When I put in 2, I'm going to have 16 over 4 plus 2 is 6, which is 2 2/3. And then I would reflect that. Now, what ends up happening, we had no asymptotes, but our graph was a little bit flatter here. And as you move up into your degrees, then that's what it does. It flattens it out. We may still have a parabola, but we're a little bit flatter here at the bottom. So I just wanted you to see that you will not always have vertical asymptotes or horizontal asymptotes. Okay, we want to look at finding then our slant asymptotes. And your slant asymptotes will be when the degree of the numerator is 1 more. So the degree is 1 bigger. Again, this is just kind of abbreviating it than the degree of the denominator. Whatever that degree is, the degree of the numerator is 1 bigger. And when that happens, then you're going to have a slant asymptote. So we will get an equation in the form of y equals mx plus b, of a linear equation. Now, the way that you go about doing this is you're going to divide the numerator by the denominator and drop any remainder. So if we have f of x is equal to x squared minus 4 over x. My degree is 1 bigger. Now I have no horizontal asymptote. You will never have a horizontal and a slant. You can have a slant and a vertical, but if you've got a slant, then you don't have a horizontal. So it's 1 bigger. So what I'm going to do is divide my numerator, and since that's just by a monomial, I'm going to break it up. And so that's going to be x. This is a remainder. So we're going to drop the remainder, and our equation's in the form of y equals. So y equals x is the equation for our slant asymptote. If we had f of x equals x squared minus x plus 1 divided by x minus 1. Okay, we can do our synthetic division. 1 minus 1, 1, divided by 1. Bring down the first one. We would have 1, that would be 0, 0, 1. Okay, remember this last number's our remainder, so we're going to drop our remainder, and our equation is in the form then of y equals, that would be x. So again, that's our identity function. And if we took this one, f of x is equal to 2x squared minus 5x plus 7 over x minus 2. Well, the degree's 1 bigger, so we have a slant. Again, we're going to do the synthetic division. If you can't do synthetic division, then you do long division. Divided by 2. Bring down our 2. 2 times 2 is 4. minus 5's negative 1, negative 2 plus 7's 5. We drop our remainder, and our equation then is in the form of y equals 2x minus 1. So this is how you get the equation for your slant asymptote. So let's go through and see then how we go about graphing these. If we took the equation y equals, or f of x equals x squared plus 4 over x. Now we're going to go through all those same steps that we did before. So we're going to look for symmetry. I'm going to plug in negative x. I'm going to have x squared plus 4 over x. Well, negative, I'm plugging in negative x. So that ends up being x squared plus 4 over negative x, which is the same as the opposite of x squared plus 4 over x. So I don't have the same equation, but I have the opposite equation. So I'm going to have origin symmetry. Okay, I want to find my y-intercept, so I'll plug in 0 for x. That would give me 4 over 0. So there is no y-intercept because this is undefined. So no y-intercept. Want to find my x-intercept, I have x squared plus 4 over x. The x-intercept is when your function equals 0, so that would be at x squared plus 4 equals 0. And there's no way if I subtract 4, I've got x squared equals negative 4, so that's not a real number. These have to be real numbers. So there's no x-intercept. All right, I want to deal with vertical asymptotes. That occurs where my denominator equals 0. We've already said we can't factor that numerator. So x equals 0 is a vertical asymptote. The degree of my numerator is bigger than the degree of my denominator, so there's no horizontal. But it's 1 bigger, so there is a slant. So we have a slant asymptote if we do our factoring or our division, which is y squared over, or x squared over x plus 4 over x. We drop our remainder, so y equals x is the equation for our slant asymptote. Okay, let's look at graphing this. Okay, we do have origin symmetry, so that's going to help us. We only have to find points on one side, and then we can reflect them across the origin. We had no horizontal, or no y-intercept, no x-intercept. We have a vertical asymptote at x equals 0. So our axis right here is also an asymptote. And you can't see that there, but it's there. We have a slant asymptote at y equals x, which is our identity function. It's going to go right through the middle here. So we have a slant asymptote. Now, what ends up happening? We know toward our vertical asymptote, our graph's either going to be going toward negative infinity or toward positive infinity. Again, we can use some good common sense. We had no x-intercepts. So our graph cannot be going toward negative infinity and then cross and approach our slant asymptote. So the only way our graph can be going is toward positive infinity and then toward our slant asymptote. It's reflected across the origin, so it would be doing the same thing. And again, we couldn't go across this way to get to our positive infinity because we'd have to cross the x-axis. So that's just good common sense. Let's pick a point though. And I'm going to pick 1 and 2. I'm just going to pick a couple of points so that I can see. At 1, substituting that into my equation, which was f of x equaled x squared plus 4 over x. So that would be 1 squared plus 4 is 5 over 1 or 5. So at 1, I'm at 5. At 2, I'm 2 squared is 4 plus 4 is 8 over 2, which is 4. So I would be here. Now, I've got to be going toward the positive infinity, coming down, and at some point I turn. And we may not know exactly how far down we dip. We've gotten pretty close. We also know then at -1, we're at -5 because there was origin symmetry. And at -2, we're at -4. So we're going toward the negative end, and then we're going toward our slant asymptote. It's a pretty cool looking graph. If we graphed it real fast, just to check ourselves, okay, we would need parentheses, x squared plus 4 divided by x. And you can see we came very close to our graph. All right, let's look at one more with the slant asymptote, and then we will finish our lesson. Okay, let's take this one. F of x is equal to 2x squared minus 5x plus 7 divided by x minus 2. So I wanted to do one that looks pretty complicated, but we're going to do it without a lot of problems. If we go through and we plug in a negative x, now again, we can use common sense here because in this numerator we have both a positive and an 1 to an even power, 1 to an odd power. And so there's not any way that we're going to have any symmetry. Before, in that last one, we had an even in the numerator and just an odd in the denominator. And so we did have origin symmetry. But here when we have a mixture, we're not going to. So, we could put in a negative x. And end up with 2x squared plus 5x plus 7 over negative x minus 2. So you can see we don't have the same equation. If we factored out a -1, we still would not have the opposite equation. So there's no symmetry. If we find our y-intercept, well, plugging in 0 into the numerator, we have 7. Plugging in 0 into the denominator, we have -7/2. So we have a y-intercept at -7/2. To find our x-intercept, we set our function equal to 0. And so that would be where our numerator equaled 0. Now, we could check to see if this one's factorable. 2 times 7 is 14. Factors of 14 that add to 5, there's not. It's not factorable, but it could be irrational. So what we would have to do here is our quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that would be 5 plus or minus the square root of 25 minus 56. Now I'm going to stop here because what that's going to give me is a negative number. Square root of a negative number gives you an imaginary number. And we are graphing only real numbers at this point. So we have no x-intercepts is what that tells us. No x-intercept. Then we want to deal with our asymptotes. Our vertical asymptote goes there. We weren't able to factor that numerator, so there were no common factors. So x equals 2 would be our vertical asymptote. Now, we have no horizontal asymptotes because the degree of our numerator is 1 bigger than the degree of our denominator. But it is 1 bigger, so we could have a slant asymptote. And we actually divided that while ago. It was 2x squared, so doing our synthetic division, it was 2 minus 5 plus 7, and our divisor was 2. So 2 times 2 is 4, minus 1, negative 2, that would be 5. We drop our denominator, so our slant asymptote would be y equals 2x minus 1. All right, let's look at graphing this information. And going back through that, we had a y-intercept at negative 7/2, which would be negative 3.5. We had a vertical asymptote at x equals 2. We had no horizontal asymptote. We did have a slant asymptote at y equals 2x minus 1. So that would mean our intercept was negative 1. We go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And just so that I have it long enough, I'm going to go down 2 to the left. Down 2 to the left 1, down 2 to the left 1, so that I can draw it just a little bit better. So we're going to have a slant asymptote there. Now, we want to get some points. Well, we've got a point here on this side of our vertical asymptote. So that tells us we're going to be going toward the negative, and we're going to be going toward the slant asymptote. And if we just wanted to go ahead and pick a number on this side to do some checking, we could. It's not necessary because we find points on each side of our vertical asymptotes and of our x-intercepts. So since we've already got this point on that side, that pretty well tells us what we've got to be doing. If you want to, we could pick another point there. We could pick 1. Now our function was 2x squared minus 5x plus 7 over x minus 2. So if we put in a 1, we're going to have 2 minus 5 plus 7, which would be 4, over 1 minus 2 would be negative 1. So that's going to be negative 4. So at 1, we're at negative 4. And just so that we know for sure, let's put in a negative 1. So if we put that in, we're going to end up, that would be still 1 times 2. So that would be 2 plus 5 plus 7. So that would end up being 14. We'd have 2 plus 5 is 7, plus 7 is 14 over negative 3. So negative 14 thirds, which would be 4 2/3. So at negative 1, we're at 1, 2, 3, 4 2/3. So that just clarifies that we're going toward our slant asymptote. We turn somewhere, and then we're going to go toward negative infinity. because we know we don't ever cross the x-axis. Now, how high up we go just kind of depends upon your function. And then let's pick positive 3. So we have 9 times 2 is 18. May need to write that part down. Negative 5 times 3 would be negative 15 plus 7 over 3 minus 2 is 1. So that would be 3 plus 7, so that would be 10 over 1, or 10. So at 3, we're up here at 10. So that means we're going toward our slant asymptote, and we're going toward positive infinity. And so we have our graph. Let's just check this one out. Okay, we need parentheses. We had 2x squared minus 5x plus 7, close parentheses, divided by parentheses x minus 2. Now, since I know my point here was 10, I'm going to go in and I'm going to change my window so that it goes a little bit higher than 10. I want my y maximum to be higher than 10. Let's just make it 20. Okay, and then if we, 20, not 2. So if we now graph this, you can see on this other one we could just barely see it. But now you can see your graph a lot better. You can see that we have a horizontal asymptote. If I went back, we didn't do this on any of the others, but let's go down and let's just graph 2x minus 1, which was my slant asymptote. And you can see your graph goes right through that. So you should be able to graph your rational functions when you have vertical asymptotes, horizontal asymptotes, or vertical asymptotes and slant asymptotes.